We alive. It's alive. Whenever I hear the word alive, I have Gene Wilder in my head next to the monster he has just created.
It's alive. Yeah, yeah, yeah.
Yeah.
Um, so did you see they released data on the first TRAPPIST-1 world today?
No,
Yeah.
no, I hadn't seen that yet. I was in Telecon land. What what
So
what all was
there's
in it?
there's 7 TRAPPIST worlds,
Mm-hmm.
all roughly Earth-sized mass,
Mm-hmm.
and 4 of them are in the habitable zone. Anyway,
Something like
3 of
that.
them, yeah.
More than
And so
two.
the first one is not. And
Okay.
like clearly this is how they're going to play this is they're going to release them one at a time. And so we got the data on the first one, and like it is temperature wise it's kind of halfway in between average temperatures of Mercury and Earth.
Yeah.
And what's really cool is that the observations perfectly matched the models that the astronomers had within a couple of degrees.
That's awesome.
Yeah, yeah. And they had a couple of other different models that were a little off, but one of the models, yeah, nailed it. And it's like it's like not as bad Mercury, but no atmosphere. So it's not Venus, right? It's
Right,
airless,
right.
but it is definitely a nasty place to live. But it's amazing. Like they were able to not detect the atmosphere. Like they were certain that they didn't
Yeah.
detect the atmosphere, that it has no atmosphere worth detecting, and they were able to detect the temperature. And it's the dimmest planetary observation that JWC has made so far. So
How did you see the result? I guess it was last week or the week before, where they had done spectroscopy of a planet. I would have called it a tiny brown dwarf, a transition object, 19 Jupiter masses orbiting a pair of 90-ish Jupiter masses brown
yep, yep,
dwarfs at about 100 AU. And so this is an object that is basically seen by the temperature of its gas pressure.
yeah.
And they were able to make out water, carbon monoxide, methane, potentially carbon dioxide. It was an iffy result.
Yeah.
And silicate clouds, where they were able to make out that there were different size particles of silicate in the atmosphere of this planet. And
Yes. Yeah, that was the
planet.
one. That was the part that everybody focused in on, was that you've got clouds of hot sand that are
Mm-hmm.
flying around in the atmosphere, but it's not like one of those hot Jupiters. This one is
Yeah.
really far away from its stars, and so its hot sand clouds and high temperature is purely due to the fact that it's a baby and is hot and still cooling down from
Yeah.
its formation, which is a
Yeah.
totally different way that you get a hot world with these features. And it's really
Yeah.
interesting to see what is the difference between this world that is brand new and still cooling down versus one that's trapped really close to its star and creating all of this sand and just through the interactions and the weather from the star.
Yeah.
So really neat, very very different world. To see one that is that far away from its star is terrific. So
And
just keeps getting better and better.
we're seeing it separate from its stars. So it's not like the star's light is polluting what we're seeing, which is the normal case when we observe planets. Is we're observing the planet's light, we're observing the star's light, we're subtracting the star's light. No, we're just looking at the planet in that case. And again, planet. It's a transition object between a planet and a brown dwarf.
Yeah.
But it's super cool, and sand is true in some cases. The thing that struck me is like, so the moon has regolith, which in some cases is basically dust-sized shards of glass. This is nasty stuff.
Yeah.
Well, this world has that dust, this basically smoke-sized particles of silicates, which is basically, imagine smoke made out of glass.
hmm
It's a bit terrifying.
Yeah, no kidding. Yeah. Yeah. Crazy. Very cool. I wonder if, like, was Jupiter like that in the beginning?
it so this is the thing that I've been thinking about is so Jupiter's smaller, it wouldn't have reached quite as high a temperature because of that whole pervnert thing that we all learned in high school. But when we're looking at hot Jupiters that formed roughly where they are, or formed and migrated in such that they never had a chance to cool, do they maintain this kind of a structure? How does it change a structure of a world to give it the chance to cool down? Because you're going to have different things form at different temperatures and then be destroyed, and not all chemistry is reversible. So
Right.
it's kind of cool to think about all the possibilities.
That's all really fascinating. All right, we should do our show.
What's our episode number?
675.
Okay, I lost my mouse. There it is. I am now the one with too many monitors.
That's not possible.
It's okay. I am now the one with a mouse pointer that is too small for the area of my monitors.
Sure, I'll accept that answer.
Okay.
Yeah.
All right. I am pressing record, and I'm getting one final drink of my soda.
Okay. I'll get one final drink of water.
Oh, I am powered purely by caffeine at this point.
Okay. Let it begin. Astronomy Cast, episode 675, Exotic Forms of Ice. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today. With me is Dr. Pamela, a senior scientist for the Planetary Science Institute and director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. It is odd to be recording this episode on a beautiful spring day, but on the day that I added it to our show lineup, it was a nasty, cold, horrible Midwestern day, and I was inspired.
Well, it snowed here.
Oh,
this
geez.
spring, so perfectly appropriate. Although my wife described it as a snow cone fight. Like it did not last long. Gloopy blobs of snow blasting around. So no, it was not, nice, light, fluffy snowdrifts, but was just like someone was pouring gloop down from the sky. It was this spring. Climate change. Ice is ice, right? What you get when water freezes? Well, maybe here on Earth, but across the universe, water could be squeezed together at different temperatures and pressures, leading to very different structures. Today, we'll talk about the different forms that ice can take. And we'll talk about it in a second, but it's time for a break. And we're back. All right. So in preparing this show, what things that I didn't even realize is that the kind of ice that we're familiar with is actually the minority in the universe.
Yeah, it's one of these things where, like, growing up, you're taught over and over in school that ice is the one solid that is bigger than in volume than the liquid that it forms from, and you're told all these things.
Right.
And it turns out that what we're learning is the special case in which liquid water is able to freeze at a rate that allows crystals to form. And as the oxygen molecules come together to form these six-sided crystals with the hydrogen atoms oriented however they will, the volume gets bigger because the molecules have to space themselves out to form these crystals. And the thing is, that very special circumstance of liquid to ice that allows crystals to form isn't gonna happen everywhere in the universe.
Right. So we've got a habitable world where you have liquid water under air pressure.
Yeah.
And as the temperature drops below freezing, then you get these crystals able to form inside the water, float to the top, and continue growing to
Yeah.
form sheets of ice. So what is that called?
Crystalline ice.
Crystalline ice. Okay.
Yeah,
So
yeah.
so from whenever you like, if you're going to serve someone a drink, you ask them, "Would you like some crystalline ice cubes in your drink?" Right?
Well, and
You
what's
go
cool,
skating at the crystalline ice skating rink.
what I love is there are pubs and bars around the world that have gone to great extremes to figure out how exactly you should freeze ice to get perfectly clear ice cubes, because the goal is to get all the crystals aligned just so that you don't have any defects. Just like a diamond, you judge it for its clarity. Well, a diamond is a crystal and ice is a crystal, and apparently we sometimes judge our ice by its clarity.
What's the trick? How do you make ice clearer than cloudy?
So it's a combination of how quickly you freeze it, and just making sure that it is pure water, free of defects. And I think I remember reading that you start with hot water and then let that go. And I don't know why that would
Yes.
be possible,
And there's
but
something like you have to agitate it, I think,
to get
so
the
that
air
it
bubbles out.
to get the air bubbles out.
Yeah.
Yeah. So you have to keep slowly mixing it to get all the air bubbles out. They'll cause little blobs of cloud inside that will then make it not clear. Yeah.
Yeah.
Um, ha-
And a quick
have you ever?
side PSA. So I've gone through life not knowing why people said use cold water to make pasta and things like that, because it's not really going to make a big difference on how quickly things boil. And it's because the cold water going through your pipes doesn't pull the irregularities off the sides of the pipes, so you actually get softer water from the cold tap than from the hot tap. So if you don't want as many kidney stones, use the cold water. Yeah, that totally blew my mind. I only learned that a
Huh,
few weeks ago.
that's
Now
really
you
interesting.
know.
Well, and in our new place, we've got a pretty big problem with hard water. So
Yeah.
before I never had hard water, and now I have hard water. Now we're learning these terrible lessons as we're cleaning the gunk off of faucets and things like that. But I had no
Yeah.
idea. That's really interesting.
Yeah.
Um, Now the clearest ice that I've ever seen was in Iceland. There's this,
Oh.
if you take a tour, there's this lake where glaciers are dropping blobs of ice into the lake, and then they go out into the ocean, and then the ocean wears them down a bit and then barfs them back up onto the shoreline, and you walk along and they're just these chunks of diamond. It seems
Oh.
like they're beautiful, and then you bring one back to the bar and they'll mix them into your drinks if you want. So it's an amazing experience. Like I think seeing geysers and waterfalls and all that was great, but seeing these shards of glass like ice
Yeah.
on
Yeah.
the shore, and I guess something, I guess the enormous pressure of the glacier to clear the ice out. All right, so we've talked about crystalline ice. Boring. Um, so let's talk about the other kind of ice.
So I first learned about this in trying to understand the different theories on why objects like centaurs out around Jupiter's orbit, and between Jupiter and Saturn, are able to sometimes become active. At that particular distance, a icy object shouldn't be getting enough energy from the sun to be thermally excited. And so there's ideas that in some cases it's landslides release energy that causes activity. But another idea is as objects move into the inner solar system, while things don't get warm enough to melt crystalline ice, they do get warm enough to transition ice from what's called amorphous ice to crystalline ice, which is a process that releases energy.
So what is
And
amorphous ice?
it is ice that comes in many different kinds of density structures, where basically you have water molecules that are so cold that if you put them all in a cup, they wouldn't form water, but they're so cold that they can't orient themselves to form crystals. So you end up with all these water molecules collecting together. The closest analogy I can think of is like dust gathering together. And as these molecules of ice come together without any orientation being dictated upon them, you get amorphous ice. So not crystalline is amorphous.
Right, right. And so if you were to like take a magnifying glass, crystalline ice, you would see all these molecules lined up perfectly. But with amorphous ice,
all over the place.
They're all over the place, but it's not a liquid.
No, and
Like,
this is where it's so weird because
yeah,
there was this truly delightful study, and I'm always amazed at how researchers get permission to do it, and it's not so much permission, but the creativity and the funding to do certain things. Or permission to use equipment to do certain things. I don't really think this is a funding issue. Water is kind of like comes out of the tap.
Yep.
Researchers took water, froze it at extreme pressures and extremely low temperatures in the vicinity of ball bearings, steel ball bearings, and essentially beat the tar out of it. And it turns out that if you have ice and you beat the bejesus out of it, like literally take a container with ball bearings in it and shake it and shake it and shake it and shake it so that you don't so much have a snow cone as you have snow, but then you put this under extreme pressure. What you have is all these disorganized ice crystals that are a powdery substance that can be considered a solid, but can behave more like a liquid. It's super weird.
But I guess that's what, like, on Earth, as we mentioned, you've got reasonable temperatures crossing the line between freezing and I guess not freezing. And then you got the air pressure. But in worlds like Europa and Enceladus, as you descend down into worlds like Jupiter, you've got varying both temperature and pressure, both vastly greater and vastly lower than what we have on Earth. So, and these give us some of these weird forms of amorphous ice. All right, we're going to talk about this some more in a second, but it's time for a break. Do you need a drink?
Yes.
All right?
Yes, I do.
Okay. Tell me you're ready.
Go ahead.
Are you ready?
Yeah.
Oh, okay. You guys say ready.
Oh, sorry. I shook my head.
Yeah. I'm not watching you.
Oh, okay. Sorry. That was stupid. Yeah. Okay.
Yeah. Okay. And we're back. So let's talk about this. Then give me some examples of amorphous ice here in the solar system in various places and how it might have formed and sort of just how it behaves.
So the most obvious one is what I mentioned. We have these objects that are not rocky asteroids, are not comets because their orbit hasn't carried them into the inner solar system yet. These are objects that formed out in the outer solar system, so out beyond 50 AU. And where they formed was so cold that as ice crystals came together, they didn't form crystals. And as gravity pulled all of these ice crystals together, it created greater and greater pressure. And so you have these objects that are made of amorphous ice. And as they migrate towards the inner solar system, they eventually get enough energy that the ice rearranges itself into crystalline ice, and we see these outbursts. Now, that is kind of cool. It isn't scary at all. And it's like, huh, yeah, that totally makes sense.
Yeah.
Now, when you carry this research a little bit further and start looking at worlds in the outer solar system and thinking about that ball bearing experiment, we have worlds like Ganymede that, while you can't really compare them to ice in a small container with ball bearings being beat up, they they do get struck by asteroids, which has a similar compression force. So
Hmm.
what you can imagine is asteroid comes in or comet comes in, some source of force comes in, strikes the surface of the earth, not the earth, of the world. So Ganymede, one of these other icy worlds. At the surface, some of that energy is going to lead to melting, but ultimately there's going to be compression waves that move through the world and have the ability to transition ice from crystalline ice to amorphous ice. Now, over time, this pressure is going to get released through the world. It's a tectonic force, just like pressure inside of the place where two plates come together will eventually release as an earthquake. And new research is theorizing that over time, the release of that pressure from ice going from crystalline to amorphous, when it goes back to crystalline, this can cause some of the massive cracks, some of
Hmm.
the strange quakes, and other formations that we've seen on the surfaces of these worlds and previously couldn't completely explain because they didn't have tectonics like we have here on Earth.
And so you've got, I mean, when we think about Europa, like we know that the surface looks very icy,
Yeah.
and maybe it is crystalline ice at that point, but then you've got tens of kilometers of ice
And
stacked on top of each other. So you can imagine the sorts of pressures that this ice is under 20, 30, 50 kilometers of pressure of all of this ice coming down on top of it. It must be extreme.
well,
And then is that kind of then rippling back up and causing some of these
so
cracks to make their way back up?
Europa and Enceladus are their own kind of special case. They
Mm.
they have more heat inside of them than Ganymede does, and this additional heat allows ocean currents. Especially with Europa, it's looking like to actually affect, to create drag forces, to build up torque forces on the ice above that is generating a lot of these structures we see. And the ice, it's still being debated whether it is consistently tens of kilometers thick or in some places just a few kilometers thick with water being able to seep out. Now, with Ganymede, you're looking at a world that doesn't have the same tremendous amount of heat built up in the core. While it may have subsurface oceans, it is going to have significantly thicker ice on the surface. And it's in these cases with the significantly thicker ice, such as with Kuiper belt objects in particular, that we're going to be looking at having this amorphous ice potentially getting formed during collision events where there was once crystalline ice and then that flip back from amorphous to crystalline again that releases energy.
All right, we're going to talk about this some more, but it's time for another break. And we're back. So what about some of the most massive places in the solar system when you think about as you descend down through the cloud tops of the giant planets of Jupiter, Saturn, Uranus, Neptune? I mean, they're called ice worlds
Yeah.
because they have ice, like Neptune and Uranus. Like if you brought them to Earth and just sort of spread them out, they would be made of ice. They'd be made of the
Yeah.
kinds of material that forms ice, different kinds of ice. Um, so what can those planets get up to as you descend down into them?
So this is yet another form of amorphous ice, where the different structures are defined by the density of the ice and essentially the chaos of how the molecules aren't aligned with one another. And they've been doing wild things like using lasers to smash things together to try and get an understanding of what kinds of ices are existing at these pressures and temperatures, where the temperatures are, it's a gas body with a lot of gravity compressing inwards. It's higher temperatures here. So here you have high pressures creating the ice because of pressure. And then the temperature is above what we're used to thinking of for freezing. So here again, we're looking at something that, think of the molecules more as dust grains that are confined together to form ices in a situation that just doesn't exist on our planet. And what is really amazing me is the creativity, and I'm just going to say this over and over, the creativity of the researchers trying to
Mm-hmm.
understand this stuff, where they are like, okay, so we see this thing. How do we get water on our planet that is at 1 atmosphere and at human survivable temperatures? How do we make the water molecules suffer the way they suffer?
Right.
And how do we explain the colors? One of the weirdest new releases I've seen is researchers have really been struggling to try and understand how Europa has the colors that we see.
Hmm.
And just like you can get different gem colors by having the crystalline structure include different impurities, whether it be lead or zinc or whatever impurities makes your different colored gems. Well, it turns out that if you have water molecules where you have different ratios of the H2O combined with salts, the ratio of the number of water molecules to salt molecules that are together forming a different kind of crystal, these different kinds of crystals can produce different colors.
Hmm.
So while it's crystalline ice on Europa, it's now starting to be thought that when we're seeing these gorgeous ruddy colored lines where there's cracks, that is extremely salty water that has frozen into a crystalline structure that is a combination of salt molecules and water molecules forming their own structure that just happens to scatter red light.
And like I know that the thinking for like Europa was that this might be some kind of, or the hope that
Yeah.
this is some kind of organic molecule that is
Yeah.
being mixed in, that you've got some kind of long chain carbon molecules that are mixed in with the ice, and maybe this is evidence of life. But what
There
you're
was
saying
hope.
is that, yeah, but maybe, I mean, who knows?
Well,
But but it seems like in fact it's that just salt mixed with water, and it's forming crystals that are taking on these strange shapes. And I think what's really interesting about a place like Europa is that when you reach the surface, whatever you created is going to last
mm-hmm.
because it's so far away from the sun, so it's not going to sublimate.
Yeah.
You're you're far enough away from Jupiter that the tidal interactions, all of the heating that's coming from that, that's happening down inside the world.
Yeah.
But the stuff that's reaching the surface is hard as rock, literally, and now is being exposed to space, micrometeorites, other debris and stuff that could be raining down on it. But it's not like it's going to be sublimating in the same way that you would get if you moved Europa close to the sun.
And it's just amazing to realize that just like carbon, we're all familiar with how it's able to be like regular everyday pencil lead versus forming complex structures with buckyballs versus forming diamonds of various colors based on what pollutants are in the crystals. Well, water really does the exact same thing, where we have the amorphous structure that's a lot like your pencil lead. We have the crystalline pure structure that you sometimes see in pubs that's crystal clear. We have the salty crystals that are a whole variety of different colors depending on the ratio of salts to water molecules, which are forming our different color crystals. It's all the same chemistry, but occurring at different pressures and temperatures with different molecules or atoms in the case of carbon.
So the thing that I recommend is do a search for that I guess ball bearing ice
Yes, it's brilliant.
experiment. Yeah, yeah, and you can really see that the lab setup that they had. Sorry, you can really see the lab setup that they had. It's quite amazing to see these fairly large ball bearings mashing ice to produce this strange shape. And as you said, right, the creativity to go like, how do we replicate an environment that is
Yes.
completely alien to Earth here on Earth?
We're going to super freeze water and beat the bejesus out of it.
Yeah, and punish it with steel. Um,
Yes.
I guess did you ever was it Cat's Cradle? Did you read that Kurt Vonnegut
Oh, no, that one I
story?
didn't read.
Yeah, and there was this thing called Ice Nine in that scientists had made this material called Ice Nine, and the thing that it did was anything that it touched turned into more Ice Nine, and so turned the entire planet into Ice Nine, and then proceeded to attempt to turn the entire universe into Ice Nine at the speed of light. And
Yeah.
so I don't think
Ice
that's
doesn't
real.
do that. No,
Just
no.
yeah, just because it's in a science fiction story doesn't mean it's true. Now, if you make strange matter, now we're talking. But no, not ice.
And
We can't get that version of ice.
and it's important to note that if you take a regular ice crystal and you super freeze it slowly, it's just going to sit there going, "Hi, I'm ice." You have to do something to it to break the crystalline
The amorphous
structure
ice.
to get the amorphous ice,
Yeah,
or have it freeze super fast so the crystal structure doesn't have a chance to form.
yeah.
So that idea of contagious ice structure, not a concern.
Right. All right. Well, thanks, Pamela.
Thank you, Fraser. And I forgot to open the file.
No.
Sorry, team. You're going to have to edit. Ah, okay. Today is, I'm going to go with that being the correct list. All right. Thank you, Fraser. And as always, thank you so much to all of our patrons out there through patreon.com/astronomycast. You allow us to pay the folks behind the scenes, Allie, Beth, Rich, who make this show possible. This week, I would like to thank a selection of our patrons. Planetar, Andrew Stevenson, Cami Razian, Paul L. Hayden, James Roger, Alex Rain, Gabriel Galfin, Sean Matt, Glenn McDavid, Arctic Fox, Karthik Vekatraman, Stephen Coffey, Brian Kilby, Dean, Corinne Demptruck, Lou Zealand, Bart Flaherty, The Air Major, John Drake, Benjamin Davies, Nate Detweiler, Benjamin Carrier, The Lonely Sand Person, Nuala, Sam Brooks and his mom, Jason Kardukas, Robert Hundle, Kim Barron, Paul Esposito, Bob Zatsky, Gordon Turner, Ron Thorson, Arts Latz Hall, Arthur Latz Hall, Mark H. Whittick, Hal McKinney, Bruno Latz, Reuben McCarthy, Time Lord Iro, Daniel Donaldson, Frank Stewart, Will Hamilton, Ian Abdullah, Jeff McDonald. And if you would like to listen to this show with no ads, go join our Patreon and get your own special access feed.
Thanks, everyone, and we'll see you next week.
Bye-bye. And then they saved.
And we saved. Grats on the camera.
Huh?
Seems to be working just fine. You
Yeah.
replaced your camera, right?
Yeah, I had to.
Not the
It
cable,
was-
the whole camera.
I was like, I'm done. I'm done
Yep.
with you.
Yeah. Yeah. Which camera did you go with?
I got the Razer Full HD. It's the one designed for streaming that Razer has.
That's cool. No, it looks good.
It's not as fancy as your system, but it was the fanciest I could afford. So that's what I got.
Um, okay. Okay.
I have no idea if I just saved that in the wrong directory. Let me check that out. I was like, I did save it. Okay, I saved it in the correct place. All right. Hi, do you have questions?
There are questions. Okay. How can you ask, what's the minimum number of water molecules necessary to make ice? 2?
I think it needs to be 6.
6?
Yeah, because it's a 6 oxygen molecules are what shapes the crystal. So
Okay. Okay. Right. Okay. They form the corners of the, is that
yeah,
3? I'm trying to think. H2O, so
and
2
so
hydrogens of O, and then there's how many vertices on the
so
crystal? But is
so
it
it's the oxygens that make the crystalline structure, and the hydrogens are just hanging out, going, "We're hydrogen."
right?
Sorry, I was overly dramatic in personifying a hydrogen
Yeah.
atom.
So is it hexagonal?
Mm-hmm.
Yeah. So it's a hexagonal plate or a thin hexagonal column, and so you need 6 formed, and
Yeah,
then you can just stack them up on top of each other. Okay.
yeah.
Um, Googler asks, what would inflate the habitat in space?
Put oxygen inside of. Well, put gases inside of it,
Hmm.
and since you're not fighting against the pressure external to the unit, um, like here on Earth, blowing up of balloons can be a bear because you have to expand against air pressure. You have to displace air. In space, you don't have to do that.
Yeah.
So you can inflate a habitat with less pressure inside it. And that is just pleasing.
So the sort of people who are famous for this was Bigelow Aerospace. They
Yes.
have
Yeah.
filed for bankruptcy.
Which makes me sad. I was rooting
Mm,
for them.
yeah, you should do a little more research.
Okay. Okay.
Um, but the but the replacement is oh man, Sierra Space, and so they're
Okay.
the ones who make the Dream Chaser,
Yeah.
and they're also making their own version of inflatable habitats.
Cool.
So you can get, and so they just tested their 4th inflatable habitat to destruction on purpose, and the next step is they're moving up the scale to full scale versions of this, and it's pretty great. The technology will allow you to put a um in a single launch 1/3 of the volume of the International Space Station in just one launch. And so in
Dang.
something like Starship, you could launch the entire internal volume of the International Space Station in one launch. And these things have all of the support structures as well, the solar panels, everything, all
Wow.
as a central column, and then it has the inflatable habitat around it, and then has the central core that has all of all of the mechanics and etc. And then it deploys these solar panels that then you can. So it's a full space station in one launch with roughly a third the internal volume of the International Space
That's
Station
so
for a
cool.
fraction of the price. So infl- inflatable habitats make a ton of sense. So I did an interview with the chief engineer for Sierra Space
Hmm.
on my channel. So if people want to see a fairly in-depth interview about how their habitat's going to work and then what the future holds. I mean, that's the fun part is they make really useful habitats. They go bigger, and you can think about other places like the surface of the moon or Mars. You just inflate a half dome, like as opposed to a you inflate a dome as opposed to a sphere, but it
Yeah.
all works really well. So I think the future is definitely inflatables, and they're
Yeah, I
actually give you
agree.
better protection from micrometeorites and things like that. When
They
you think about,
flex.
yeah, they flex. You surround them in Kevlar, right? When you think about a module on the International Space Station, they're aluminum cans, and but if you want to up armor them, you can, but then that adds mass, etc. And so instead, you just inflate your habitat, and the membrane that is holding the atmosphere in is also the protection. So it's a really great
Yeah,
way to do this. Um,
it's cool.
yeah, Hal McKinney said might airtight igloos work as space habitats. Yeah, so on the surface of like the moon or Mars, they work really well as well.
Yeah, The Expanse talks about that some.
Okay, okay. Hal McKinney also asks, could you make a lens out of ice, a
Yeah,
telescope?
yeah.
Yeah. Let's see if someone's done this. Telescope lens made of ice. The problem is back to that idea with, yeah, so people have made them.
Broken Symmetry over on Twitch writes,
Wow.
my steampunk heart loved Fraser's phrase, the future is inflatable.
The future is inflatable. Yeah. And made of brass.
Yes.
Um subs for the sub gods, likes for the algorithm. Series Kaylee asks, is there only one triple point of water? Does that depend on the
Yes.
pressure?
Well, so on any given world, there is a single triple point. So
Mm.
I believe it's a volume. Let me double check that. I may be lying. Chemistry is not my strong suit.
Yeah, so what I'm seeing is at high pressures, water has a complex phase diagram with 15 known phases of ice and several triple points, including 10. So when the pressure goes up, you have different triple points
Yeah.
between ice, water, and then
It's a
supercritical
line through
fluid.
a volume.
Yeah. Very cool. Hal McKinney also asks, does light refract differently through water depending on what state the water is in?
Yes. Yeah.
And then he also asks, is water's tendency to crystallize or expand the reason cryogenics is not the reality sci-fi sometimes portrays it as?
Yes.
Yes.
Yes, it is.
Yeah. Yeah. That is the big tricky problem
Yeah.
is how do you freeze people without the ice crystals expanding and tearing their bodies to pieces and turning
And
you into mush?
and this is where we're seeing more and more sci-fi that instead discusses the idea of scanning people. So we saw scanning in Alistair Reynolds' books. We saw scanning in Altered Carbon. We saw scanning in Scalzi's books.
Mm, yeah.
Um,
Yeah. But because it's destructive.
yeah,
The scanning process is destructive.
yeah.
Um, but I
Neil
mean, we see
Stephenson's.
creatures. I mean, we know creatures can do it.
Have you read Neil Stephenson's The Fall yet? You
No,
need to. It's
is
so
that new or is that
good.
older?
It came out like the first year of the pandemic.
Okay, I'll check it out. Um, so what was I going to talk about? Oh right, yeah. So we know there are creatures. So there are frogs that
Yeah.
can freeze solid. Like you literally can bang them on the table, and they bang, 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 and then it will defrost
But
and
then
be
chunks
fine.
might come off, so don't do it.
Don't do it. Yeah. And then there are creatures that can slow their metabolic rate. They can't freeze, but they can slow their
Yeah.
metabolic rate down and hibernate. So, and the frog somehow like replaces its blood with antifreeze to
Yeah.
some degree,
Yeah.
or something that can then, or like some kind of enzyme into its blood that then resists the crystallization so that it can then go back again. So, I this sounds like a solvable problem. I think we will eventually have some version of freezing that will allow us to go for long periods of time, different from hibernation, which would let you decrease your metabolic rate, and maybe you would live a little longer, but not hundreds, thousands, millions of years in deep sleep. Any other questions? Or I'm about to give an AI update. I guess it's gonna be an AI update.
So there's something that I want to do with AI that I'm wondering if you've done yet.
Hmm?
Have you fed AI images and asked it to describe them yet?
No, I don't have that access with
Okay.
ChatGPT. Do you?
No, it's
Mm.
one of those things that I'm looking into. I'm trying to figure out how to do it.
Yeah, I don't think you can. You have to like they haven't rolled that feature out. Like, do you have the pro version of ChatGPT?
Not yet. I need to get
Okay.
that.
Yeah,
Yeah.
I would definitely get that because that gives you access to 4, and they don't have it yet, but I think when you get access through the API, you can feed them images as well as get access to the 32K model
Okay.
that has a memory of 32K, so about 20,000 words, as opposed to the current one only gives you about 3,000 words, 4,000 words, but the other version gives you a much larger memory. But the part that's crazy, and I like, we're 9 days after release, and then of GPT-4. Anyway, 2 weeks after GPT-4, and now they've released this new thing called plugins. And what it lets you do is let ChatGPT reach out to some other service on the internet to do functionality. So, for example, we know that it's terrible at math, but
Yeah.
now you install the Wolfram Alpha plugin. It knows how to use it, and it can then go, oh, I need to do a calculation here, and then it reaches out to Wolfram Alpha, feeds Wolfram Alpha all the data via the API, receives the answer, and then presents it to you. So, so the thing that it was terrible at, or one of the things that it was terrible at, is now solved. Right? Like, just boom, they go to Wolfram Alpha, and it will calculate all of this stuff, no problem. But it will also browse the web. It will also shop on Shopify. It will order groceries on Instacart. It will do, and then it's also connected up through Zapier, which is like this IFTTT,
Yeah.
it's this hub of APIs. And so now suddenly you can run against, I think, like 5,000 different services through this API
Is
call.
it tied in with Alexa or do you still have to type everything in?
Well, I mean, it's all programmatic. So you have one application that is
Hmm.
running commands through the API, and then it's essentially all it is the ChatGPT is like this little piece of intelligence in the middle.
Yeah.
So you say, um, here's a comment that I got from on my YouTube video. Can you please extract out all of the questions? And then for any of those questions, can you run the calculations on Wolfram Alpha? It's like, no problem, right? Here's your answers, right? So you remember like when we used to do the
Uh,
question shows,
yeah.
and you'd be like, please don't give me stuff that's going to make me do calculations.
Right, right.
Well, now you can just do calculations, and it will. The point being that the ChatGPT will understand the question and then queue up the queries into Wolfram Alpha to run the calculations or to generate the formulae or whatever. So like this we like our brains are incapable of imagining how this can go awry, but it will absolutely
No.
go awry, right? Like when you use Zapier, for example, you
Yeah.
connect up your Gmail account.
Yeah.
And so then it can read through your Gmail account
Yeah.
and then take action based on things in your Gmail account. And so you could go through my Gmail and order anything that I think I want. And then suddenly things start showing up from Amazon because it just ordered all this stuff for you, right? It's dangerous. A friend of mine described this like ChatGPT is not very smart,
Right.
but it is like an infinite number of dummies, hardworking dummies who are tireless, hardworking dummies. So this part, like I don't even know what we can do with this. Like my brain is, and I haven't gotten access to it yet. But one of those does feel to me like begin the apocalypse. Like, I'm sure it's in there
Yeah.
somewhere, right?
Yeah.
Visit every website and try to exploit every single um vulnerability you can devise, right? And it's the you can devise part
Yeah.
that is
Yeah.
what makes it scary, because up until this point, if you want to exploit you can do it automatically at scale, but you're running algorithms. You're saying,
Mm-hmm.
you know, scan the code, search for this vulnerability, scan the code, search for that vulnerability. If vulnerability found, then run vulnerability patch. But in this one, it's just like, just go check out the website and just make yourself comfortable and see what you find, right?
Yeah.
And
Yeah.
ChatGPT can do that.
S-
So
So
scary.
I'm rereading Moon is a Harsh Mistress over on my personal Twitch stream at Starstrider. And it it starts with a computer that is given so many neural connections and so much information that it wakes up essentially.
Mhm.
And the person that's interacting with it has to periodically abort requests because computers don't know when you're being literal or not.
Right. Yeah.
And yeah, we're gonna hit that stage.
Yeah. And so, like, I mean, I think people are worried about, like, is it going to wake up and is it going to want to kill us and all that kind of stuff? And it doesn't have to. Like, it just has to do things at scale that are not what we intended.
Yeah.
And interesting, sometimes very bad outcomes will happen. And so I
Very
think this is
expensive outcomes are going to
very expensive, very
happen.
bad outcomes will happen. Yeah. And I think
Yeah.
we're going to see a million of them shortly as this technology pervades every part of our life. And the question is just, the hope is we get a handle on it before it gets more powerful. But we are definitely in a race,
Yeah.
right? The meme is like, you've got on the one hand, you've got this distinguished academic saying that we really
Mm-hmm.
need to be very careful and we need to carefully study and make sure that the artificial intelligence is aligned with our interests. And the
Yeah.
next line over, you just got like two idiots running, going, "It's a race! It's a race!" Right? like Google,
Google
Bing,
Bard, yeah.
yeah, Google's Bard, Bing Chat, all of these are now just going at top speed,
Yeah.
trying to get these features and functionality. Like, to open up this level of intelligence
Yeah.
to the internet with these
Yeah.
kinds of APIs is just crazy,
Yeah.
right?
The deep fakes that are coming out.
Yeah, yeah.
I was on Midjourney last week, and I don't have a paid account. I need to get a paid account. But there was someone generating images of Macron sitting amongst garbage in front of the Eiffel Tower.
Yeah.
And it's like, wow, okay, that I'm hoping it's for an opinion piece.
I'm sure we've all seen the one of the Pope wearing his puffy jacket, white
Yes.
puffy
Yeah,
jacket.
yeah,
Yeah,
yeah.
yeah. So Carolyn B is asking, I do historical research and a lot of texts come in that aren't machine readable. Example, wills in an elaborate
Hmm.
script. Will they ever be?
Oh,
That
yeah.
that sounds like it could do it. Like you can definitely take pictures of elaborate script and things, and ChatGPT will. I mean, it has that capability. It hasn't been rolled out widely yet, but yeah, that
Hmm.
absolutely sounds, and translate it into whatever language you want,
Yeah,
as good as a
that's
human translator.
there was a talk I was hearing a few years ago before the pandemic. It's the trip where I got detained in Amman for having a audio recorder that
Mhm.
looked dangerous. Be careful on what audio recorders you have with you when
Right.
you're
Don't
traveling through
take a blue
Jordan.
snowball with you.
Yeah,
It looks
this
like a bomb.
this was
Yeah.
the H4 with the crossed microphones that looks like a taser.
Yep.
Yeah, so I heard a speaker talking about how they've been using AI algorithms to translate handwritten ancient Hebrew texts where Hebrew leaves out all of the diacritical markings and all of the vowels. And so trying to translate it is extraordinarily difficult. But because these algorithms had been trained with so many different texts,
Hmm.
they were able to go through and replicate what a human would do by reading things within context.
Wow.
And were often clearly faster, but just as accurate or more accurate because they were able to look at more combinations than your typical human mind will latch on to.
Wow.
So,
So,
yeah.
so the other thing that I mentioned, like, so they've given it this API access, and then the
Hmm.
other thing they're doing, and again, this is still I haven't gotten access yet, is it'll code Python.
Hmm.
So it runs a Python interpreter
Yeah.
inside of it that it can access for itself. And so up until this point, you want it to write code, you you say, write me a game of Pong, and it gives you the code, and then you copy paste that into your interpreter, and then you run the code in your browser, whatever.
Yeah.
But now the new version, it has a built-in coding environment. And so you could be like, write me a simulation of solar system movements, and then suddenly a little animated GIF pops up in the screen and it's showing you the solar system. And it wrote the code and then is
Yeah.
running the code in the chat. Or you say, like, make me a video game, and then it makes you a video game, and you're like, yeah, but now make everybody blue. And so now everyone changes to blue in the video game. Or run, you know, here's a piece of audio, extract the first 10 seconds of the audio for me, and then you upload the audio to it, it extracts the first 10 seconds and then gives you back to it, or extract the
Yeah.
first few frames from this video file. Like it can do anything that
Zine Zine made
with
the really cool comment of translating whales and dolphins.
translating whales and
Like being
dolphins.
able to take
Yeah,
whale song and dolphin uh, communications and within context be able to begin to translate what these different noises actually are trying to communicate.
the other thing that I saw someone do was make a predictive language model. So they use ChatGPT to code a predictive language
Yes.
model inside of itself. So it made its own mini version of ChatGPT inside of itself. Is that crazy?
Yeah,
Like,
yeah,
like I am such a technology booster. I am early adopter on all this kind of stuff, and I am freaking out.
yeah,
Like,
yeah.
this is too fast. Slow down. Put on the brakes. Somebody sort out how dangerous this stuff is, or
I
at least give me access.
I saw a comment last night where it just like made so much sense with all of these different things and all of the monitoring that's going on. It's called surveillance capitalism,
Hmm.
where people are making money by surveilling what everyday people are doing and how they're interacting and what their data is, where we are now the product.
Hmm. Yeah,
and
if you don't
and
pay for
it's
that's the quote, right? If you're not paying, you're the product.
right. And that just that phrase surveillance capitalism is something that was just like, ugh, this was not predicted in any Aldous Huxley book.
Oh, totally was. Not in Aldous Huxley, maybe, but a lot of people were thinking about this.
Ugh.
Um, yeah, yeah, like you are. Each one of us is being mapped down through machine learning algorithms
Yeah.
down into hundreds or even thousands of data points that predict us at what stage of life we are, where we're going, what we're doing, and what we want to buy all the time.
Yeah.
um, and and I think, like, we definitely need to get away from that, or at least
Yeah.
they need to pay. Like, if they want my data, they need to pay me, or I will release that data for my purposes. Like, I would like a new car, please. Here's my data,
Yeah.
but you have to, and then you can recommend a car to me. But that as soon as we're done this transaction, you have to forget you ever met me,
Yeah.
and I'll drive away with my car.
It's
That is
it's
that's the way this has to go.
it's
Or
also the right to be forgotten legislation they have in the EU.
mhm. Yeah, yeah. It's again, like, I'm baffled at how quickly this stuff is growing. Like, we may not be approaching the technological singularity where computers are making themselves faster, but we are definitely approaching the sort of information singularity where this stuff is
Yeah.
advancing so quickly. I can't even wrap my head around it. And I
Yeah.
still I can't even express how weird things are going to get when you're allowing this artificial intelligence to sit in the middle of every single interaction that's done between you and your computer and between beings.
And I think it was the TV show, not TV show, the novel that was admittedly a TV show, Altered Carbon, where they have the lead character sitting in basically a pod hotel,
Hmm.
and he has to watch a certain amount of advertising or get charged.
Right. Yeah. That's funny. Arjun is asking, isn't somebody working on having the large language models show their work or give footnotes?
I don't
Yes.
know.
Yeah. Yeah. So a lot of people are trying,
Okay.
but and it can be done at very small versions of it, but at the scale that everyone is using. So it's like you can understand what it's doing at the smallest possible iterations, and there's a lot of really interesting tricks that researchers are using to get these language models to express some of the things that are like some of the weird behaviors. So what was it, Magikarp?
I don't
There's
know.
like something, yeah, there's essentially you can put in one word and it will replace that word with Magikarp, and so it studied a certain kind of text, and then they removed some of that training data halfway through, and yet it still remained as like this ghost in the system that then it can still generate given the right kinds of prompts. So there's people definitely trying to work on this, but it's so hard to do. So the only like AI company that seems to be really focusing on safety is one called Anthropic, and they're ex OpenAI people, and they've got their
Okay.
version called Claude, which appears to be fairly um saying something's different about my audio.
Yeah, your audio suddenly changed slightly. I don't know if you budged a cable, but everyone can still hear you, so I wasn't worried about it. It
Huh.
happened while we were doing questions. And I have touched nothing except for my own microphone, my own
Okay, let me,
earbud. So
so I redefined my regular mic. Did that change anything?
I didn't
No?
hear a difference.
No. Cables. Okay. So one cable. Cable. Yeah, don't want that. Did that make any difference?
I didn't hear a difference, but I don't know.
It's gone very quiet. So is there anything that you've got in your application?
No, I touched nothing. Okay, I'm hearing that it does sound better.
It
Bobolo
sounds
is
better.
saying, um, yeah. Broken Symmetry and Boboleo have both said that you're sounding better. And if I mispronounced your name, Boboleo, I'm not
Hmm.
wearing my glasses and I can't tell
Okay.
all the letters in your name, and I apologize.
We've reached the end of our hour, so we might as well wrap
Yeah.
things up. So thank you everyone for hanging out with us today. Maybe that's it. As soon as I reach the hour mark, then it just starts to dial me back down until we just fade away. Thank you everyone for hanging out with us today. Thanks to everyone who asked us questions, YouTube and on Twitch. Thanks to all the moderators. Thanks in advance to the audio editors and producers and video editors that are going to have to deal with what we are
Yes.
hurling your way. And we will see all of you next week for how AI is freaking out Fraser.
All right,
All right.
everyone.
See you,
We'll
everyone.
see you next week. Bye bye.